welcome to another video. In this video, we're talking about vector calculus, right? What does it mean when we say vector calculus? The idea is very simple. Now, it is the combination of vector and calculus. We implementing what we know in vector towards calculus, right? Hello, are we together? Okay. Now, what we know in vector is that our interest in this case is the direction. What we know from our Cartesian coordinates, this is x, right? This is y, and this is what z. Introducing this to vector, we have this to be what I, this to be what j, and this to be what k, right? These are the respective direction. So all we are going to be doing here is we using this direction in calculus, right? Now let's take this example. Let's take this example. They said a particle moves along a curve. A particle moves along a curve whose parametric equations are a particle moves along a curve whose parametric equations are what we have on the board here. X equal to e exponential. We have y equal to 2 cos 3t. Okay, and we have z equals to sine 3t. Now, are we together? The question says, I'll repeat again. The question says a particle moves along a curve whose parametric equation are what we have here, x being equal to this, y equal to this, and z is equal to this. Find the velocity. Find the velocity and acceleration. Find the velocity and acceleration at t equals 0. At t equals 0. Now, the idea is very, very simple. What we know is that we are giving two questions here, right? The first one is what? Velocity. Abi? And the second one is what? Acceleration. What we know from differentiation is that the application of differentiation is that when we differentiate once, what do we have? When we differentiate our displacement, right, we have velocity. Then when we differentiate velocity, we have what? Acceleration. Now, the first task is we giving, this is a parametric equation given, right? What it means is that we need to represent it in form of vector form. Basically, what we've seen earlier that vector has the direction to be what? I, j, and what? K, right? Meaning that we need to give this parametric equation a vector equation, right? Now, meaning that we have r. Let me use r as the reference now. Saying that r being equal to what? Xi plus what? Yj plus what? Zk. This is what I want to be using. So what it means is that I'm giving x, I'm giving y, and I'm giving z, right? Meaning I'm going to what? Substitute the respective value. So therefore, by doing that, r will be what? Exponential minus ti, right? Plus 2 cos 3tj plus what? Sine 3t what? K. Okay, we've been able to convert or express the given parametric equation in what? Vector form. Now, the next task is to calculate the vector and what? Acceleration. And what we know is that when we differentiate this equation, let's say displacement in this case now. When you differentiate displacement once, we get velocity, meaning the r dt. Then when we differentiate the r dt, which is our vector, we have acceleration, that is the square r over what dt square. Abi, now let's see what we have from here. Now the r, okay, for x component, what do I have on my x component? I'm having that r is r equals to what? Exponential minus ti. So what it means is that I should differentiate for the x component. So therefore the r over the t will be equals to minus exponential minus ti. Are we together? Now for the next one, the y component. I have r equals to, what do we have here? R equals to what? 2 cos what? 3tj. So what I need to do here is find what? The r over what? The t. Now the question is, how do I find the r the t? From differentiation, the techniques of differentiation, I can use my chain rule here, right? So chain rule, applying chain rule to this, okay, applying chain rule, we have r equals to what? 2 cos 3t, right? Now let u equal to what? Cos 3t, right? If u is equal to cos 3t, it means that r is equal to what? 2u. If u is equal to cos 3t, it means that we've represented, anywhere we see cos 3t, we will put u there. You understand? This is the original equation. Then we've said an assumption now. Let u equals to this, meaning original equation can be written as what? 2u. So therefore I'll be working with this guy and I'll be working what? With this guy here. So the derivative of this one multiplied by the derivative of this one will give me the r over what? The t. Abi? Now from here, from 1 now, which is u equals to cos 3t, then how do I get my the u over the t? Now to get the u over the t, the rules of differentiation is that differentiating sine x, what do you have? Differentiating what? Sine x, what do you have? Cos x, right? Differentiating cos x, what do you have? Minus sine x. Same thing applicable here. Differentiating cos 3t, but observe, cos x is different from what? Cos 3x. Okay, before solving this, let me quickly explain this. You know, in differentiation, if y is equal to what? Sine x, we said that dy over dx, is equal to what? Cos x, abi? And if y is equal to what? Cos x, we said that dy over dx is equal to what? Is equal to minus what? Sine x. Now let's change our question. If y is equal to sine x, dy dx is what? Cos x. And if y is equal to what? Cos x, dy dx is equal to what? Minus sine x. Right? Now let's change our question. What if we have y equals to sine, y equal to what? Sine 3x. You know, normally from here, dy over dx should be what? Cos what? X. It should be cos 3x. Let's write that down, cos 3x. But you need to multiply it by the value we are having here, which is 3. So therefore, for this case, dy dx should now be what? 3 cos 3x. Hope you get what that means. Similarly, if y is equal to what? Cos 3x, We know that the y over the x is equal to what? Minus sine 3x. But you need to multiply it by the value we have there, which is what? Times 3. So we have minus 3 sine 3x. So that's the idea. Now, back to what we have here. If it is equal to this, the u dt will now be what? The u dt will now be what? Minus 3 sine 3t. Abi? Any question on that? Okay. From r equals to 2u and r equals to 2u, the r over the u is equal to what? Is equal to what? 2. So therefore, to get the r dt, our interest initially was what? The r dt. So to get the r dt, will be the product of this times this. So I have 2 times minus 3 sine t. Sine what? 3t. By doing that, I have minus 6 sine what? 3t. In what direction? What will be the direction here? Don't forget y component. In the direction is what? J. Do you understand? Any question? Now for z component, for z component, for z component, for z component, what do we have here? We have r equals to what? Sine what? Sine 3t. Applying the same idea here, it means that the r over the t will be equals to what? 3 cos 3t. Then your direction k, right? Meaning we've been able to differentiate velocity in x component, velocity in y component, and velocity in what? Z component. Then bringing all the velocity together will give you the velocity you are asked to calculate. You understand? So by doing that, we have that the r over the t is equal to exponential, is equal to minus exponential, okay, plus 2 cos 3tj, minus 6 sine 3tj, plus 3 cos 3t what? K, right? So this is the velocity. So therefore, velocity is equal to minus exponential minus ti minus 6 sine 3tj plus 3 cos 3tk. But the question says what? Go back to the question. Read the question again. What do you have? Okay, a particle moves along the curve whose parametric equations are given to be this, right? Find the velocity and acceleration at t equals to 0. Now, we've gotten velocity to be this, right? At t equals to 0. What it means is that substitute the value of t. Anywhere you see t in this case, substitute the value of t there. So therefore, you have v is equal to minus exponential minus 0 I minus 6 sine 3 minus 3 times 0 is what? 0. Just put 0. J plus 3 cos 3, okay, 0 as well. K. Now let's press our calculator. What do you have? Huh? Where? Okay. What do you have? exponential minus 0. Okay, I'm having minus 1 I
minus 0 plus 3 minus 0 plus 3 minus 0 to minus 3
are we together? Are you also having the same value here? Minus exponential minus 0 raised to the power of minus 0 will give you minus 1I. Then this will give you 0j. Then this will give you 3k. Which implies that velocity v is this, right? I'm coming. Are we together? Any question on how we got this? Now, we said at t equals 0, we substituted the value of t in what we've differentiated. Anywhere we see t, right? That's what we have here. Then, by the time you input this in your calculator, you have minus 1i. Then all this will give you minus 6 sine 0. Sine 0 is 0. 0 times minus 6 is still 0. That's why you're having this here. Similarly, because 0 is 1, 1 times 3 will give you 3k. Then we eliminated 0. Then we have minus I plus what, 3k. But one more thing to go. You are not done. The question said find the what? Find the what? The component, right? The component. The question says find the component of the velocity of. Okay, find the velocity. Okay, this is how it works. This is the velocity in terms of direction. Right? We want to get the magnitude of velocity. This is the direction of this velocity. We want to get the magnitude. No, generally, or note, generally, to get the velocity, to get the magnitude of a velocity, you have v is equal to what? The square root of each direction, meaning x square plus what, y square plus what, z square. But what we have here, we have that x is equal to what? Minus 1 minus 1i, right? Yes. Yes, minus 1i, or better still, minus I. We know that. Then for z now, we have what? 3k. So what it means is that as this me implementing this formula, okay, y in this case is what? Minus 0j. So therefore, velocity will now be square root of what? Minus 1 square plus what? Minus 0 square plus what? 3 square. We have this is 1 plus 0 plus 9, right? So therefore, velocity v is what? Square root of what? 10. Then you are done. That's the answer. Any question? Okay, we've calculated for velocity, right? The next one is what? Acceleration. The next one is what? Acceleration. What we know about acceleration is that acceleration is the derivative of what? Velocity. Okay, let's work that out here. So if velocity v is given as, or it was calculated as minus exponent. Give me the value that is there. What do you have there? Okay.
minus 6 times 8 3 cos 3
So from here to get the acceleration in this case, acceleration Acceleration will be what? The what? The v over the t, which implies that the square r over what? The t square. Are we together? Now let's get this done. What do you have? It means that the v over the t is equal to what? Exponential minus ti. Abi, you are applying same product through here. What we did initially, recall when we have something of this, when we said we have 2 cos 3t, we said this 2 multiplied by the what? Derivative. How do we solve for this? How do we differentiate this? How do you differentiate this? You differentiate this by the same idea, the idea you use here. That's what you are going to use here. So by doing that, you have minus open bracket 6 times. Now, when we differentiate sine 3t, what will be the derivative? That will be what? 3 cos 3t. Abi? That will be what? 3 cos 3t. J plus open bracket 3 times, this one will be what? Cos 3t. That will be what? Minus 3 sine 3t. Okay. So from here, we have exponential minus ti minus, what do you have here? 6 times 3 is what? You have 18 cos 3tj. Abi? Then this will be what? Minus 9 sine 3tk. At t equals 0. At t equals 0. What it means is that we should substitute the value of t equals 0 anywhere we have t here. Okay? So we have the v over the t being exponential minus what? What do we have here? Please, what's the value? Call the value we have here for me. Minus ti. Oh yeah. 18 cos 3tj. Minus 9 sine. At t equals 0. So we have this I minus 18 cos 30 j minus 9 sine 30. We have exponential. This will give us 1. 1 times I is still what? I. Minus 18. 3 times 0 is what? 0. Cos 0 is what? 1. Times 1. Minus 9. 3 times 0 is what? 0. Sine 0 is what? 0. 9 times 0. Okay. We have I minus 18j minus what? 0k. Or, okay, let's do it that way. Minus 0k. This is my what? dv over the t. Which is the what? Acceleration. But we want to get the magnitude of the acceleration or component of the acceleration. This is the direction of the acceleration. Hence, what you have to do is what? Acceleration, the component will now be equal to the square root of what? 1 square, the x1, open bracket, plus minus 18 square, right? Plus minus 0 what? Square. Then from here, we have square root of 1 square plus 18 square. Okay, what do you have? Let's get this done. What do you have? Square root of this will give me what? 324. 324. Let me confirm that. 18 times 18. Okay, that's square root of what? 325. This is 1 plus 324. That's 325. So therefore, in short form, what do we have? Square root of 325 will give us what? 5 root 13, right? So we've gotten the value of acceleration, we've gotten the magnitude and the component of acceleration to be what? 5 root 13. Similarly, we've calculated the value of velocity, the component of the velocity to be what? What was the value we got for component of velocity? Square root of 10. So that's what the question asks us to calculate. So that's what we are meant to do. So in the next video, we will take another example explaining components and direction of velocity and acceleration. See you in the next video.